Morning, everybody. It's Saturday, April 11th. Got my morning cup of Joe, or in my case, it's morning cup of Joel. So, um, gonna show you a couple more types of problems this morning. First one, it says suppose a degree 5 polynomial with rational coefficients has 5/8, negative, square root 5, and 7i as zeros. Find the other zeros. Well, as soon as we read that it's a degree 5 polynomial, that means that it can have up to 5 answers. So we can have up to 5 answers. It gave us 3 of the answers because, as I said last time, answers and zeros, roots are all the same thing. So we have 3 of them, and we have to find the other ones. And here is the rules of the ball game on a problem like this. As soon as I see that negative square root 5 is one of my answers, then the opposite of that is also going to be an answer. So since negative square root 5 is an answer, positive square root 5 is also going to be a 0. It's also going to be an answer. And as soon as I see that 7i is an answer, that's a complex number, well then the opposite of it, or the conjugate of that number, will be the other answer. So the conjugate of 7i is negative 7i. And that's all there is to that problem. So I know we can have up to 5 answers because it's a degree 5 polynomial. That means the highest exponent on the variable in that equation would be a 5. It can have up to 5 answers. And those would be the other 2. It gave us 3 of them, and those are the other 2. Let me give you one more example of that type of a problem. So, say we have a degree 5 polynomial with rational coefficients, and it has 2/3 square root of 13 and 4 minus 5i as zeros. So once again, we got a degree 5 polynomial. It gave us 3 of the zeros, and it wants you to name the other ones that are out there. Once again, as soon as you see a square root of a number is one of your answers, the opposite of that square root will also be an answer. So since the square root of 13 is an answer, negative square root 13 is going to be another answer. And then I see this complex number, 4 minus 5i, is an answer. So its conjugate is going to be an answer as well. Conjugates are 2 quantities that are exactly the same except for the sign in the middle. So the conjugate of 4 minus 5i is 4 plus 5i. So those would be the other 2 answers to this degree 5 polynomial. And that's all there is to a problem like that. So now I'm going to move on to a different problem. Totally different type of problem, and it's going to say something to the effect of use the rational zeros theorem to list all possible rational zeros. So use the rational zeros theorem to list all possible rational zeros. All possible rational zeros. So if I give you a polynomial function like this, say we have 3x to the 4th minus 2x squared plus x minus 9. Say that's our polynomial function, and I want you to list all possible rational zeros. Well, the formula on this that you have to follow is the factors of the constant over the factors of the lead coefficient. So that's what you need to remember on this problem. Factors of the constant over the factors of the lead coefficient. So in this polynomial function, the negative 9 is our constant, and the 3 is the lead coefficient. Coefficients are numbers in front of variables. The lead coefficient is the number in front of the highest exponent term. So in this case, factors of the constant, all the factors of 9 are positive -1, positive -3, and positive and -9. And when you follow this formula, you got to put positive and negatives in front of each factor as a possibility. So yeah, no matter whether that was a +9 or -9, it doesn't matter. Whenever you answer this question, you put plus and minuses in front of all your factors over the factors of the lead coefficient. Well, the lead coefficient is a 3. The factors of 3 are 1 and 3. And then after you do that, I want you to actually list them all out so I can actually see them all, and I know that you know what you're talking about. So how I do it is I just start with the top left number. 1 over 1 is 1. 1 over 3 is 1/3. Notice I put positive and negatives in front of each one of those guys. And then I move on down the road to the next guy in the ball game. 3 over 1. 3 over 1 is 3. 3 over 3. 3 over 3 reduces to 1. We've already listed 1. We don't need to list it again. So I'm done with that number. Move over to the 9. 9 over 1 is 9. 9 over 3 is 3. 9 over 3 is 3. We've already listed it. We do not need to put it again. So when I list them all out, there are all the possible rational zeros. Now, not all of those numbers are zeros of the polynomial function, but if we were to graph this out, this guy would cross the x-axis at one of these, at one or some of these locations, because these are possible zeros, and zeros and x-intercepts are the same thing. So probably show you one more real quick, and then I'll be done for this lesson. So say our function equals 2x to the 5th minus 3x to the 4th plus x plus 6. Say we have that as our polynomial function. Once again, if you have to use the rational zeros theorem to list all possible rational zeros, it's going to be the factors of the constant over the factors of the lead coefficient, and you put plus and minuses in front of all your factors. So in this case, the constant is 6, and in this problem, the lead coefficient is 2. So all the factors of 6 are 1, 2, 3, and 6. Because factors are all the numbers that go into a number evenly with no remainder. All the factors of the lead coefficient is 2, while the factors of 2 are just 1 and 2. So there we have it, and then of course I want you to list them out. So once again, if I were to list all those out, here's how I do it. I just start to the left and work my way over to the right. 1 over 1. Well, 1 over 1 is 1. 1 over 2 is 1/2. Notice I put positive and negatives in front of all my numbers here. I'm done with the 1. Move over to the 2. 2 over 1 is 2. 2 over 2 is 1. I've already listed it. I don't need to list it again. Move over to the 3. 3 over 1 is 3. 3 over 2 is 3/2, also known as 1.5 or 1.5. Done with that. Move over to the 6. 6 over 1 is 6. 6 over 2 is 3. I've already listed the 3. So if I list them all out, right there are all the possible rational zeros of this polynomial function. And that's what I got for you today. Have a great weekend, and I'll shoot out some more lessons next Monday and next week.